Hello, everybody. It is Sunday. It's August 1st, and we are heading into the 13th week of our online astronomy course. So first of all, got to tell you, it's my birthday, so happy birthday to me. And this is going to be an exciting week because we are going to leave our home galaxy, the Milky Way, and start studying other galaxies in the universe and find out what the rest of the universe looks like. Now, behind me, you can see the Milky Way in the background. And I got to tell you, this is a very wide angle picture. It stretches basically from horizon to horizon. And so in the center of the picture, you're looking south. And on one side, you're looking east. On the other side, you're looking west. So it's a very wide angle photo of our Milky Way. And all the stars you can see here in the sky, and all the stars you ever see in the sky, belong to our Milky Way galaxy. But there's one exception to that in this picture. And I'll just have you take a look over my shoulder, just over my shoulder there. You can see that little smudge of light. And that is the Andromeda galaxy. The Andromeda galaxy is 2.5 million light years away. And it's the farthest thing you can see with your naked eye. And a little bit later, I'll show you how to find that in the sky, because it is really cool to see something that old, like that old, arriving to you from something so far away. So let's get started here. We are going to be talking about galaxies, and it's amazing because for as many of the stars that are in our galaxy, and you know there are hundreds of billions of stars in our galaxy, there are as many other galaxies in the known universe as there are stars in our own galaxy. So that's huge, a huge number of galaxies out there. And we're going to learn about the different sorts of galaxies. Some are flat and have a spiral structure, something like our own Milky Way. Some have a bar in the center and still have a spiral structure. And in fact, our Milky Way is one of those barred spirals. Some are like a big football shape collection of stars. Those are ellipticals. And some are just sort of irregularly shaped. And those are called, surprise, irregular galaxies. And we'll be learning all about them. And, you know, galaxies are not island universes. They don't, live their lives separately. They actually interact with each other. They can collide. They tug on each other with their gravities. Now, when I say galaxies collide, I don't mean stars collide, because, as you know, stars are really far apart, but still the gas and dust in those two galaxies can collide and heat up. And that makes for some spectacular fireworks, as you'll find out in this module. And I think perhaps most surprising is the discovery that was made about 100 years ago, that all of the galaxies in the universe are moving away from all of the other galaxies in the universe. And that is called the expansion of the universe. And it was discovered that galaxies that are twice as far away from us are moving away from us twice as fast. So you can think about the expansion of the universe sort of like you can think about, I've linked this rubber band. I've linked several rubber bands together. And those knots that are in the rubber band might represent galaxies. And the rubber band, the part of the rubber band between the knots represents the space between the galaxies. Now I'm going to hold one end of the rubber band over here, just on the left side of the screen. And then I'm going to move just my right hand, and you'll watch this space between the galaxies expand. So I'm not going to move this hand on the left side of your screen, only the right hand side. And this is going to represent the expansion of the universe. So watch how the positions of the galaxies change. I'm holding this hand very still, and here it goes. So notice how the galaxies are all moving away from this hand here over on the left, which represents us on Earth. We're in our Milky Way galaxy. Here's our Milky Way galaxy. That's where I'm pinching the rubber band with my hand. And then as the universe expands, we see all those other galaxies moving away from us. But take a look, they all didn't move the same distance. You know, the one that's farthest on the right, the one that's farthest from the Milky Way, the knot that's on the right there, when the universe expands, goes all the way to the edge of the screen there and back. So it moves a long way. Now, the knot that's in the middle of those three only moves not nearly as far. And the galaxy that is closest to my hand, the galaxy that is closest to the Milky Way there, doesn't move nearly as far as the others. And in fact, if you were to put your fingers on the screen as I do this, you'll find that the galaxy that's closest to the Milky Way, which is here, right here, in this hand, the knot that's closer to the Milky Way moves out a certain distance. The second knot from that moves out twice as far. And the third knot from that, the one on the one closest to this hand on the right, moves out 3 times as far as the knot that was on the left. So let's do that one more time, and maybe you can watch that happen. Here we go. Expand these galaxies. And look how far they went. And notice that they did this in the same amount of time. And so that means the galaxy that was 3 times as far away from us moved away 3 times as fast, because it moved 3 times the distance in the same amount of time. The knot that was in the middle there, the middle galaxy, moved away from us twice as fast as the closest knot. And so that's what Edwin Hubble discovered. Edwin Hubble discovered that a galaxy's speed away from us depends on its distance. And a galaxy that's twice as far away moves away twice as fast. And a galaxy that's 3 times as far away moves away 3 times as fast. And that's called the Hubble Law, or Hubble's Law. And that is the basis for our understanding of the expanding universe that we all live in. So we'll be learning all about that. And you'll also learn about how, when we look at galaxies, we're looking back in time, right? If I look over my shoulder here at the Andromeda galaxy, I'm seeing that galaxy as it was 2.5 million years ago. And that's just the closest large spiral galaxy to us. If I look at some other galaxies, I can look back, hundreds of millions and billions of years. So we can see those galaxies as they were billions of years ago. And that means we see them when they were very young. And we don't see the sort of galaxies we see today. We can see active galaxies, galaxies that shoot out from their centers, jets of material. And those are called active galactic nuclei, AGN for short. And these AGN are very active galaxies, and you'll learn all about those. You'll also learn about how galaxies come in clusters. Our own Milky Way galaxy belongs to a group of about 40 galaxies. It's a rather small group. It's called our local group of galaxies, and we're in it. Andromeda there is in it, and about 40 so other galaxies are in it. And we'll learn how there are clusters of galaxies called superclusters, and how in between those clusters of galaxies there are vast empty spaces called voids. So we'll be learning all about that, and we'll be learning about the existence in the universe of something we can't see, which is called dark matter. It's called dark matter because it doesn't shine. And apparently, we know it's out there because we can detect its gravitational influence, but it doesn't shine at all. It doesn't interact by, with other particles except through its gravity. And so you'll be learning all about dark matter. A lot of cool stuff, a lot of amazing stuff in this module. So I hope you enjoy it. And as usual, I want to go to Stellarium here to show you what you can see in the sky. And this is such a great time to start talking about other galaxies. So let's go to Stellarium. Here we go. Here's Stellarium. You're seeing Stellarium as it is on the night of, this happens to be August 4th. So this is Wednesday, but we're facing northeast. So we're looking in the northeast sky, and we haven't looked at the northern constellations very much, but we did once. And you might remember that this constellation up here is Cassiopeia. It's the big W that's in the sky. That is Cassiopeia. Here, let me put up the star patterns and the constellation patterns and names. So there's Cassiopeia. And there's a big empty square here. That is the body of Pegasus, the horse. And here is the horse's head. And here are two of the horse's legs. Now you might think that this in back is the horse's hind leg, but no, it's not. This is the constellation of Andromeda. Andromeda is the daughter of Queen Cassiopeia. And here, maybe I'll just put up the figures here for a second. Here is Cassiopeia. Here is Andromeda. And if you look at Andromeda, it looks as though she's tied to something. She's chained to something. And that's part of the mythology. In fact, if you know the constellations and you know about Greek mythology, you can actually read these stories of Greek mythology in the constellations. And the idea is that Cassiopeia, Queen Cassiopeia, was bragging of her beauty. And Andromeda didn't like that at all. Her daughter Andromeda didn't like that and let her know. So Queen Cassiopeia got mad and chained Andromeda to a rock to be eaten by sea serpents. But fortunately, Andromeda was rescued by the hero Perseus. Andromeda married Perseus, and they went off to rule the Greeks. So they went off to be Greek rulers. Anyway, that is the story behind those constellations. I think that's sort of cool to know. But if you take a look at, if you can find Cassiopeia here, you notice how these stars here at the end of Cassiopeia form sort of a pointer. And if you follow that pointer down, before you get to Andromeda, to those stars I was showing you, those lines, you find this little smudge in the sky. I'm going to turn off the lines. So here's Cassiopeia. You follow those pointers, you come to this smudge in the sky. If I start to zoom in on that, you'll see that that is the Andromeda galaxy. It's very large in the sky. It's 6 times the width of the full moon, but it's very faint, so it's hard to see unless you're under fairly dark skies. So this is Andromeda M31. This is, there's another small galaxy near it right here. This is M33. And up here's another galaxy, M31, and these two galaxies orbit the Andromeda galaxy. These are gravitationally interacting galaxies. And the M stands, by the way, for their entry number in a catalog made by Charles Messier. So these are Messier objects. Messier was looking for comets, and he kept being distracted by these other things in the sky that weren't comets. And so he made a list of things to avoid looking at. And there's some of astronomers' favorite things in the sky now. So that is how to find Andromeda. The Andromeda galaxy, maybe go out, you can see it with binoculars. I'll zoom out again. And I'll remind you to find these stars in Cassiopeia. Follow them over to that smudge in the sky. And that's how to find the Andromeda galaxy, 2.5 million light years away from us. So lots of cool stuff in Module 13, and I hope you enjoy learning about it. As always, if you have questions, you can always contact me by email, discussions. You can meet with me on Zoom or in my office. But we're drawing to the end of the class, and next week we'll learn about where all of this came from, the Big Bang. So enjoy this, and I will look forward to seeing you next time. So until then, bye-bye.